All right. Now we're going to jump into the next part of 1.2, which is looking at symmetry. So we've already talked about how we can identify intercepts to help us graph manually. But another aspect of graphs that's good to know is the symmetry. So there's three types of symmetry that we're going to be looking at. So we got symmetry in the x-axis, the y-axis, and the origin. So how we test for those, we have a few different processes. All of them similar and not very stressful. So if we wanted to see if there's symmetry with respect to the x-axis, then whenever x, y is on the graph, we should also know that x negative y is on the graph. So that's kind of going to be the key to seeing if there's symmetry. We're going to be able to plug this in to the equation and see what happens. And so we'll check that out in a second. When there's symmetry with respect to the y-axis, then again, when we have xy on the graph, then negative xy is also on the graph. So another way to kind of think of it is, if you wanted to start with an easy point, usually you would start in the first quadrant, and both things are positive. So if both numbers are positive here, the y value gets negated, so it's folded over the x-axis, and now it's in the fourth quadrant. If it was in the first, now it's in the fourth. Very similar here. If we had a point in the first quadrant and it's reflected in the y-axis, now it's flopped over into the second quadrant because the x value is negative and the y value stayed the same. And then the last case is when you have with respect to the origin. And then again, if we have something in the first quadrant, now it gets bounced down into the third quadrant because both the values become negated. So let's see how we can do that manually to really check for symmetry. So if we have our equation here, y equals x over x squared plus 1, let's do the x-axis first. So the x-axis, we want to negate the y value but leave the x value alone. So if we negate the y value and we leave the x value alone, we want to see if we can get it to look like the original, if there's any mathematical way to do that. And if there isn't, then that answers your question. So is there any way we can make this look like this? You can move the negative to the other side, but you can't get rid of it. So y equals negative x over x squared plus 1. Doesn't look like the original, so no good. So let's try the y-axis. So now we want to keep the y value the same, but we want to negate the x value. And we got to negate it anywhere it happens. So there's two spots that we had to negate it. Now, again, parentheses are important. If you leave them out, then that's going to mess things up. Now, if we simplify this, we can see that we can't make it look like the original. Still got that extra negative in there. So, no good. So now let's do the origin. And so we got a negative y and a negative x. All right, and now if we want to simplify it, well, this negative on top and this negative on the left of the equals are going to be able to cancel each other out. And we already know that if you square a negative, it's going to disappear. So this will get us back to the original. So this has symmetry in the origin. And that's it. All right, what about this one? All right, we're going to do all three checks. Yeah. So if we have our x-axis, again, we want to negate the y and not the x. So negative y squared. So there's what we started with. And we can see the negative is going to cancel out. And so we do have symmetry in the x-axis. What about the y? So negative x cubed, oops, 3, don't forget the negative. So y equals negative x cubed plus 4x. And if you wanted to go a step further and factor out the negative, you could. Make sure you factor correctly though. So we'd end up with that, which doesn't look, and don't forget the squares in there either. So we can see that it's close, but it's not the same as the original, so this is no good. And take a wild guess about the origin. Remember, we're negating both of them, so it's kind of like a combination of the x and y axis together. We know the y's will get back to the original when they're negated, but the x's do not. So we can kind of assume that that one's not going to work. So this has got symmetry in the x-axis. So 3 checks, fairly minor in their mathematical, difficulty, but you need to do all 3. So, all right, let's move on to the last part of this section, which is looking at circles. So circles are an interesting application of the distance formula and how we can look at the distance between a curve and a point. So we have our basic elements that we need though. We need to have a distance, so we're going to call that r, and we're going to have a point that it's a distance away from, and that point is going to be called hk, the ordered pair hk. And now if we use the distance formula, we can make a spin-off of what the equation would look like. So we're going to cut right to the chase, and our formula will look like as follows. So any point on the circle that has a radius r or distance r away from point hk is going to look like this. So x minus h quantity squared plus y minus k quantity squared equals r squared. So let's quickly get some applications going. So if we want the standard form of the equation of the circle with the given characteristics, the endpoints of the diameter are 3, 2, and negative 9, negative 8. Now we can draw a sketch if you want. So 3, 2 we know is in the first quadrant, negative 9, negative 8 is in the third quadrant. So I'll kind of go fairly quick here. And again, it doesn't have to be perfect. So somewhere down here. So those are the endpoints of the diameter, so we know that the circle is going to be somewhere kind of in between. Something like this. So we need to find the equation of it though. Well, the first thing that we need is to know where the center is. The center we can kind of guess is somewhere around here, but we don't want to guess, we want the precise center. So how would we do it? Hopefully you're screaming at me, midpoint, midpoint. Because remember, the midpoint should be right where the center of the circle is. So let's find that center. So we'll take 3 plus negative 9 and divide that by 2, and then the 2 and the negative 8. And divide that by 2 as well. So that's going to give you what? Negative 6 over 2, which looks like a negative 3. And 2 plus a negative 8 is a negative 6. Negative 6 over 2 is a negative 3 as well. Well, isn't that interesting? So we were fairly close on our sketch. You know, doesn't look quite right, but my drawing's not the best either. So, but that should be the center of your circle. So now that we have the center, what else do we need? We need the radius. So how can we get the radius now? We know the center, and we have one of the endpoints of the circle, so we should be able to get that radius. So let's find the distance between those 2 points using our distance formula. Now, again, if you wanted to just kind of write in some of that information, just so that way we have it. So we got 3 minus a negative 3 squared, and 2 minus a negative 3 squared. So that looks like 6 squared, which is 36, 5 squared, which is 25. Oops. So it looks like we got a 61 there. Square root of 61. Now, should we change that to a decimal? We can't really reduce it. I would leave it alone for now, because your formula wants it squared. So square roots are not going to be an issue. So now we can get our answer. So we want to plug in our numbers carefully. So we got not a line, but an x minus a negative 3 squared plus y minus another negative 3 squared equals square root of 61 squared. Now obviously you want to pretty that up. So x plus 3 squared plus y plus 3 squared equals 61. Not too bad. All right, last application. So we can find an equation based off of a point and a center, or a point and a radius. Now let's go in reverse. If we have an equation, we should be able to pull that information out. So if our equation of a circle is x minus 2 squared plus y plus 1 squared equals 49 over 4, what is the pertinent information we need to get a sketch? So, first thing we should be able to get from this is our center. So, should our center be negative 2, 1? Oh, no, no, no. Remember, the formula is specific in how it writes it. So, just to go back, we got x minus h. So the minus is already in there. So when it's a minus in here, it's actually a positive h for your center. Same idea with your k. So don't be tricked into doing that. You have to switch those signs. So if it's a minus 2 here, it's a positive 2, plus 1 is a minus 1. So there's your center. And now your radius is going to be based off of that 49 over 4. So remember, the end of the equation is r squared. So this is r squared. Now, technically speaking, we said before, when we have something squared equal to a positive number, there are technically 2 answers to that. There's a negative and a positive, but can we have a negative radius? So let's just square root each of those, and we get 7 over 2. And if you like decimals, which I know many of you do, we could say that's 3.5 or 3.5. So now we have all we need. So let's first plot our center to negative 1. And we want a radius of 3.5. Now, if you're drawing this by hand, easiest way to do it is to just go north, south, east, and west from your center. So we want to go 3.5 units. So 1, 2, 3.5. 1, 2, 3.5. 1, 2, 3.5. 1, 2, 3.5. And there we go. Now, again, this is a sketch. So just try your best to draw that circle in there. And as long as you're trying your best, I mean, don't draw a diamond or something like that if you're doing these by hand. Try to draw a curve. So, but that wraps up this section though. So hopefully that all made sense, but feel free to send me your questions if you have any. And stay tuned for the next video, which we get into 1.3. Take care.